After a heavy, low-country storm clears, it is completely normal to see a few wide, reflective puddles sitting on a flat commercial roof. At first glance, a little residual water looks entirely harmless. The clock starts ticking the moment the rain stops. A properly designed roof system needs to clear that water and dry out within 24 to 48 hours. If the water remains pooled in the exact same spot past that 2-day window, the structure is no longer functioning as a roof. It is acting as a permanent basin. That quiet pool of water is the very first visible symptom of an active, compounding threat to the building's structural integrity. Standing water is dangerous because of one hidden variable: its sheer physical mass. This diagram shows a 1,000 square foot flat roof section. A puddle just 1 inch deep adds roughly 5,200 pounds of load. Instead of distributing evenly, gravity concentrates this multi-ton weight directly onto a single, localized section of the underlying framing. That intense pressure forces the framing to physically bend and sag. This initial deflection, completely invisible from the surface, triggers a catastrophic chain reaction. That initial structural sag creates what roofers call a feedback loop, a mechanical cycle that accelerates the damage with every passing storm. Because the roof deck is now slightly depressed, it acts like a larger funnel. During the very next heavy rain, this new low spot captures a greater volume of water than it did originally. This cross-section illustrates how extra water translates to exponentially more weight, pushing the heavy spot further down into the framing. The cycle repeats. Rain falls again, filling the depression with a heavier load, bowing the deck further. Over time, the pond inevitably expands, growing deeper. By simply altering its own geometry under the pressure of gravity, the roof is actively tearing itself apart. While the structural deck groans under the weight below, the surface membrane faces a completely different crisis up top. This thermal illustration shows the extreme environmental contrast on the roof surface. The ponded water acts as a heat sink, keeping the submerged material cool, while the adjacent dry membrane bakes in the intense low-country sun. This temperature clash causes the materials to expand and contract at completely different rates. This process, known as uneven thermal movement, literally pulls the roof in opposite directions, physically ripping at the seams, flashings, and joints. A normal, brief rain shower might flow harmlessly over these microscopic stress tears. But when water sits over those defects for days, continuous immersion pushes moisture right through the tiny pinholes and cracks created by the thermal stress. The building's waterproof defenses collapse entirely under the combination of time, tension, and persistent pressure. The moment that standing water slips beneath the stressed surface membrane, the damage goes into hiding. Looking closely at this cross-section, you can see how the water behaves once inside. Instead of dripping straight down, it spreads horizontally through the porous insulation layer, traveling far away from the initial entry point. Inside that dark, enclosed space, the wet insulation loses its ability to regulate building temperature. Steel decking begins to rust, fasteners corrode, and the damp environment becomes a breeding ground for mold. All of this severe internal decay happens quietly, while the interior ceiling directly below remains completely unstained and completely dry to the naked eye. Relying on a brown water stain on your ceiling as an early warning system ensures that maximum internal decay has already occurred by the time you realize there is a problem. Smearing a bucket of generic sealant directly over a persistent puddle is a wasted effort. It ignores the fact that the physical geometry of the roof has changed. To properly fix the issue, roofing professionals must conduct a rigorous post-rain diagnostic inspection to find the precise mechanical failure creating the basin. This architectural schematic shows what a real diagnosis looks like. It requires mapping the exact perimeter of the pond, tracing the actual path of drainage flow against the intended slope, and systematically probing the integrity of every seam in the area. Restoring a positive slope that actively sheds water requires correcting the physical environment itself. That might mean clearing blocked scuppers, replacing crushed insulation, or repairing the sagging structural framework. Every subsequent rainstorm that hits a compromised roof adds more weight to the feedback loop, accelerating the damage. Time is the single greatest enemy of a flat roof. If you manage a commercial property and see water lingering days after a storm, You must escalate the issue before that water makes it inside. MasterRoof Mount Pleasant specializes in these exact structural evaluations, equipped to identify the root cause of complex drainage failures in the Lowcountry climate. Contact and protect your building from the top down.